Unit 6.3 Numerical Model. What is a numerical model? A numerical model is a model of sport performance based on numerical factors, e.g. numbers and units. They use numerical time-stepping procedures to obtain the model's behavior over time. It is an object evaluation. Kinetics, the study of forces that cause motion, and can be classified into two groups, linear and angular motion. Linear motion is when all the parts of the body move in the same direction at the same speed. In basketball, an example of linear motion is when a player is coming down from a jump shot and all their body parts are going in the same direction at the same speed. Angular motion is when the body moves in a circular path around the axis, so all parts move through the same angle, in the same direction, and at the same time. In basketball, when bringing the ball up the court, sprinting, your body parts are all moving in different directions, but in a circular motion around the body. Projectile motion is a combination of linear and angular motion. In basketball, bringing the ball up the court, changing direction to get past the defender uses projectile motion. Kinematics, the study of describing movement, for example, displacement, time, velocity, etc. In basketball, it's when the basketball players move around the court when playing defense or when on offense when running a play on court. How are numerical models created? You need to use the ideal numerical model of performance for an activity. Measures the numerical factors appropriate to that sporting movement against the ideal data. 3 ways to produce a numerical model. Literature-based, from information from reliable research journals, coaching publications. Athletes-based, data from an athlete's performance. Combined approach, get an average ideal numerical model from using literature and athletes' data. Evaluation of numerical model in practice. By recording images, you can make data from still or moving images. This helps as the sport is dynamic and you can record it live. When it is happening, as you will get inaccurate results. To get data from the athletes, we used labs at Brighton University to measure linear motion. Force plates were used that recorded the athlete's speed over short distance. It was repeated 4 times and the mean average was calculated for each athlete. A drawback from the method was that to get accurate results, the athlete had to make sure they hit the force plate, so it felt awkward to run. Scalars and vectors. A scalar measures magnitude, not direction. Examples of scalars are distance, speed, mass, and time. In basketball, you use distance to move up and down the court. Use speed when beating a defender when you are attacking, or by tracking back on defense to get basket side of your opponent. Vectors measure direction as well as magnitude. For example, displacement, velocity, acceleration, and momentum are all vectors. A vector has a magnitude, direction, and a point of origin. In basketball, you use velocity when sliding on defense. Use acceleration when you get beaten on defense and have to turn and run back to get in front of the attacker. Speed and velocity. Speed is the rate at which something moves. You use speed in basketball when your team has won a defensive rebound and the center passes to the point guard and you take off down the court to score. Velocity is the speed of movement in a specific direction and is the rate of change of displacement. In basketball, an example of velocity is when the guard uses velocity to bring the ball up the court, jogging in one direction, and when the defender presses at a faster pace, you cross the ball to start sprinting in the opposite direction. Distance and displacement. Distance is how far something travels, e.g. a sprinter running 100 meters. In basketball, the distance is from one end of the court to the other. A basketball court measures 25 times 15 meters, and the game is 40 minutes long. A player uses distance on the transition from defense to offense when ball and the players sprint up the court to score or set up a play. If a player runs up and down the court 50 times, the court length is 25 meters, then the basketball player's distance traveled was 1,250 meters. Displacement is how far he travels from the starting position to the finishing position. So for the 100-meter sprinter, if he ran 100 meters but then turned around and decided to run back to where he started, his displacement is 0. He didn't end up anywhere different. In basketball, displacement is where the players first set up on defense at the beginning in the game to where they end up at the end of the first quarter. So if they run up and down the court 50 times but stay in the same place when back on defense, if playing a zone defense, then the displacement would be 0. Acceleration. Acceleration is physically defined as the rate of change in velocity. In basketball, when the point guard is bringing the ball up the court and is being pressed by a defender, then the point guard goes one way, jogging, and then crosses the ball and sprints in the other direction to blow past his defender. This change in speed is acceleration. Force time graphs. Force. Force is the product of mass and acceleration of an object or person. It is measured in newtons. Force is a push or pull factor that alters the state of motion of a body. Principles of force offer guidance for teaching sport techniques and leveraging training strategies that require the development of force. Pushing or pulling in basketball, the force present are gravity on the ball and player, the mass of the ball and athletes, air resistance, resistance of the surface, and force applied by the player. Newton's first law, inertia. An object at rest stays at rest, and an object in motion stays in motion, with the same speed and in the same direction, unless acted upon by an unbalanced force. There are vertical and horizontal forces. You measure force in ground reaction force. If there's no net force, there is a constant velocity, or stationary force is a push or a pull that will alter the state of motion. Change the object from a resting state to a moving state. So in football, if you kick the ball then you are adding force. Force can alter resting positions. In basketball, when the ref has the ball in his hands to start the game and then he throws it up to start the game, changing the direction of the object. In basketball, when the point guard passes the ball to the shooting guard and he passes to the center, it can cause it to accelerate at different rates. Force can also change the shape of the ball. Newton's second law of motion. The acceleration of an object is directly proportional to the magnitude of the force applied. In the same direction and inversely proportional to the mass of the object. For example, a tennis ball is harder to accelerate than a table tennis ball. Acceleration in basketball is used if you want to make a long pass. You would need to apply more force to the ball. Newton's third law of motion, reaction. For every action, there is an equal or opposite reaction. When a basketball hits and makes contact with the ground, that's the action. The basketball bouncing back up is the reaction. A basketball player pushing a ball down is the action force, and reaction force is when the ball bounces back up. Direct force and eccentric force. Direct force is the line of the force. It is through the center of mass. The resulting motion is linear and called a direct force. Eccentric force. If the line of force passes outside the center of mass, the motion will be angular and called eccentric force. Impulse. Impulse equals force times time impulse. This is the measurement of the force applied for a specific time. The greater the applied impulse, the greater the increase in velocity. It depends on the time the force is exerted for the same size of the force applied. In basketball, when going for a dunk, in basketball, your maximum impulse will be applied. Momentum. Momentum equals mass times velocity. Example, if you have a short impulse in basketball, it's because the ball has less contact time with the ball. If the ball has longer time on the ball, it means the impulse is higher. Stability. Stability is defined as resistance to both linear and angular acceleration. In most cases, athletes are trying to increase their stability in order to prevent unwanted movement. For example, in basketball, when playing defense, you bend your knees to increase your stability as your center of mass is lowered. However, in the same situation, athletes want to be unstable to change direction in order to perform their skill. In basketball, if a player or basketball changes in velocity, then the magnitude of the direction will also change. Acceleration is both positive acceleration and negative acceleration. To increase the stability, you have to increase the base of support and line of gravity, which keeps you more balanced, whereas if your base of support and line of gravity are not lined up, then it reduces the stability as you are less balanced. Center of mass. Mass is the amount of material or matter an object has. If you have a wide distribution of mass, you are more stable and you go slower. If your distribution of mass is in a smaller space and not spread out, then the person would go faster and less stable. The center of mass of a body is where